Welcome to your specific heat capacity lab. When you get to your lab bench, there's going to be a copper slug. That copper slug stays at your lab bench all period long. This copper slug is for task B. You're going to find out the temperature of your Bunsen burner flame using algebra and the specific heat capacity of copper. This is your Labquest device. You're just going to use the Labquest device as a thermometer today. And while the thermometer is in your calorimeter, you're going to be constantly spinning. If you are lazy and let go of this and just let it sit in your calorimeter and touch the metal cylinder that's in there, the water won't mix. The population of higher kinetic energy water molecules next to the metal slug won't evenly distribute throughout the entire population of water molecules within your calorimeter. So you've got to stir continuously to mix. This is your calorimeter for task A. Your calorimeter shouldn't have any holes in the bottom, and it has a hat. The calorimeter is like this, and you stick the thermometer in like this, and you stir the water like this. It's easy. This is your calorimeter for part B, but we'll get to that. Be patient. The fastest and most efficient way to do part A is to measure your water. Remember, milliliters equals grams for water. And so you pour your milliliters of water, whatever you measure, that equals the grams of water that are in here. Find your initial temperature, of course. Write everything down on your data table that you're making on your lab. And then once you have your initial temperature, you're going to come over here to one of the hot water baths and bring your thermometer over here too. Find the temperature of the hot water bath. It should be close to 100 Celsius. As you can see, there are 3 different types of metal slugs in the hot water bath. All these hot water slugs are going to be in the bath, all these hot slugs, at equilibrium temperature with the water that's in the bath. So they should be close to 100 Celsius, but don't take my word for it. Bring your thermometer over here and measure. Be smart and read this when you're there. These are just for part 1 of the lab. This is where you're going to get your hot slugs. When you're done with your hot slugs, you're going to take them over to the fume hood. And you're going to be smart, and you're going to read all of this. And you're going to put your cooled slugs back in here. The reason being, you don't want somebody else to come back and get their second slug out of here. And lo and behold, that second slug hasn't had a chance to warm up to equilibrium temperature with the water that's in here. And then they get bad results because they assume their metal is at the close to 100 Celsius, but it might actually only be at 50 or 60 Celsius, warming back up. All right, so cool slugs go in the fume hood when you're done with them, and the hot slugs you get from one of these 2 stations in the middle of the lab. I think the best and most efficient way to do part A is to go right up to the hot water bath with your calorimeter. And you've got your crucible tongs. You're going to reach in there and you're going to grab one of the ingots and you're going to put it in the water that you've already measured the starting temperature of. And you're going to put your hat on and you're going to insert your thermometer in here and start stirring. And start stirring and stirring and stirring and stirring until the temperature of the water in the calorimeter tops out. It's going to warm because the water's cooler than the metal, and thermodynamics allows us to predict that the energy will flow from a high temperature to a low temperature, and it will warm the water. Then you can do your calculations. So I'm back at my lab bench, and I've been stirring for a while. My thermometer measured a temperature rise, and then it plateaued. And when it plateaued, I wrote that high temperature down, took my thermometer out, took the top off, reached into the water, got my ingot, and took it all the way over here to the fume hood where cooled ingots go and put it in that bath. Here's a pro tip for part A. There are 3 different metals for part A. None of them are copper because we're reserving that copper slug at your lab bench for part B. There's one that's gold in color. There's one that's equivalent in weight, just by feel. They're both pretty heavy. The one that's equivalent in weight and doesn't look like gold is magnetic. And the one that it looks like gold appears not to be magnetic. And then there's a really, really light one. Just so you're differentiating between the 3. The really light one is also not magnetic. I was just reminded of one key step. Don't forget, before you put, for part A, your ingot back in the cool ingot bath in the fume hood, before you put it back, make sure you get its mass. Zero your scale, get the mass of your ingot. All these ingots have different masses, and put that back in the fume hood to warm up for next period. For part B of the lab, I think I just said for part B of the lab, or at least I wanted to. For part B of the lab, you've got this copper ingot that has been at your lab bench since you walked into the lab. And I want you to get the hottest full blast double blue flame you can get with your Bunsen burner and cook it. Cook it at least for 2 minutes. We want it to be at equilibrium temperature with the hottest part of the Bunsen burner flame. While you're doing this, your partner measured out the water for part B and put it into your calorimeter for part B. We're using the larger calorimeter because we need space to hold the copper ingot in the water before dropping it through the bottom. If you take an 1100 degree Celsius copper ingot and you drop it into this paper cup, it's going to go right through the bottom. So once you're happy that your ingot is at equilibrium temperature, you kind of got to guess, and time is your friend here with the Bunsen burner, then you'll hold it in the water. Don't forget to get your starting temperature of your water. Always start with cold tap water. All right, we've got our starting temperature. We're going to take our ingot, hold it in the water, don't drop it to the bottom. Not dropping it in the bottom. And then we're going to hold it there. And then drop it. Put the top on, or you can use the top too from part A because it fits very nicely. And then get in there and start stirring until the temperature of the water maxes out. As soon as the temperature of the water maxes out, you've got all the data you need to answer all the questions on the lab. All right, our temperature topped out. Of course, I'm just pretending. You're going to reach in there, grab the copper ingot, and if you haven't measured the mass of that copper ingot yet, then you need to wait for it to cool down to your touch and dry it off and then weigh it. I highly recommend weighing your copper ingot before you get it wet. All right, weigh everything, measure everything, and then you'll have all the data you need to calculate your specific heat capacities of the 2 metals in part A and the temperature of your Bunsen burner for part B. Remember to leave this copper ingot here at your lab bench all day. Good luck. Thank you.